Welcome everybody. My name is Thorsten Grabs. I'm a program manager on the Azure SQL database team. Today we're going to talk about building multi-tenant SaaS applications with Azure SQL database. And I want to start us all out with showing you a demo. And the demo is for a SaaS application that we call Wingtip Tickets. So it's about selling tickets. And let me walk you through the experience here. So it's an application that's running in Azure, and you essentially get onboarded into the application as a concert hall, or let's say a theater or a music club that has events and wants to sell tickets to their respective customers. So here is one tenant of this SaaS application. It's called Contoso Concert Hall, and you can see there's a couple of events coming up, and I can click on the tickets button here, and it takes me into a seating chart, and I can then sign in with my account and purchase tickets for these events. And Contoso Concert Hall is not the only tenant in the system. Obviously, there are others. Let me show you two more. Here is a somewhat different tenant. It's a judo club, but it also has events coming up and might want to sell tickets for the event. And then the third one here is Fabricum Jazz Club, again selling tickets for a couple of events. And you may notice that some of the customization is different. So we're showing different pictures, different images for the different tenants. And the application, the demo application, has about 30-odd different tenants that we can work with. And let me tell you a little bit more about what we typically see as requirements for building these multi-tenant SaaS applications in the cloud. So obviously, one way to structure this is to think about what are the requirements that each individual tenant will have versus what are the requirements that we run into when working as the SaaS provider building that multi-tenant application. Let's start with the tenant-specific requirements here. A lot of them evolve around the concept of isolation. And you can think about it like we want to be able to secure different tenants differently so that a single tenant has access to any other tenant's data. You also may notice that some of the tenants have different workloads and different demands. So you want to make sure that, that the performance is isolated between different tenants. So no tenant will become a noisy neighbor to another tenant. A third isolation scenario to think through is backup and restore. So if something goes wrong with one specific tenant, you want to be in a place as the SaaS provider to easily restore that tenant's data back. And then there are other requirements around customizability and troubleshooting on a per tenant basis. And last but not least, elasticity. So if one of your tenants grows over time, you want to have the ability to scale up the capacity for that specific tenant. So that gives you some sense around the tenant-specific requirements. Let's now move over to the cross-tenant requirements. Obviously, one there is the ability to add and remove tenants over time. For instance, adding lots of tenants if your application grows or becomes viral at some point. You might also have existing tenants from an existing on-premise offering, and you ideally would like the ability to easily migrate those existing tenants into the cloud. Then there are database maintenance operations, like for instance, if you're storing your data in a database, you want to update statistics or maintain your indexes. And then there are reporting scenarios where you want to pull reports across all of your tenants, for instance, see which are your busiest tenants, which are your most profitable tenants. And then a big area with a lot of requirements is changing your application. So if you make an application change, it requires adding a table or adding a new column to an existing table. How do you roll this out into production in your SaaS application? And then overarching all of these aspects is obviously cost. You want to make sure that whatever you're building is cost effective. So you're going to take a close look at the cloud provider resource cost and what you're paying your cloud provider. So If we take tenant isolation as one dimension and the cloud provider costs and the ability to share resources across tenants as dimensions, then you end up with a two-dimensional space that you see on the slide here. And a very simplistic view allows us to structure the different application patterns that we have seen with customers in this space. The first one is that you essentially put all of your tenants' data into one single, potentially very large database, and you have shared tables that are shared among all of your tenants, and different rows in that table just carry different tenant IDs to disambiguate between different tenants. That obviously gives you great resource sharing because all the tenants are sharing the same resources from the same database. However, it's difficult to establish isolation between your different tenants. So that's one problem. The other problem that you're going to run into is as you're hitting the scale limits of that single database, you run into a problem, and one way to fix that is to essentially distribute your data across a number of databases, still following the same shared table approach where different tenants have different tenant IDs in their rows. That's typically called sharding, and obviously it gives you a somewhat lesser degree of resource sharing and somewhat more isolation because different tenants in different databases cannot see each other's data. Now, moving along that line, you can also think of an approach where you put each tenant into its own database. We call it single tenant per database approach. And you can follow that model. It gives you great isolation because each tenant is well contained in its own database and doesn't share any resources with other tenants, which gives you great performance isolation. But it's very easy to run into a situation where you over-provisioned capacity across all of your tenants when following this approach. So if you think about the trade-off across these different models here, what you're essentially seeing is you're getting into increasing deployment and manageability costs as you increase the number of databases, while on the other hand, you have increasing costs to implement isolation as you go with fewer databases or a single large database. So what I'd like to walk you through today is how Azure SQL Database helps you solve that trade-off, that dilemma, by establishing a new pattern that allows you to run the single database per tenant model in a very cost-effective way by using a new capability that's called elastic databases in Azure SQL DB. So having set this context, let's take a step back and look at some of the moving parts for a typical SaaS application in Azure. And the demo SaaS application that I showed initially is following exactly that architectural blueprint. So starting at the top, requests typically come through Azure Traffic Manager, and then they're routed to, let's say, a cloud service instance, a cloud service role that can be very scalable, load balanced. You can use auto-scale on that. And then underneath the covers of that cloud service, we are using here in this picture the single tenant, single database per tenant approach, where each tenant or each customer of the SaaS application gets their own database. That makes it very easy to scale the application. You simply add new databases to your data tier, and then each database is allocated to a tenant, and the cloud service routes to the tenant's database. This can be done with a simple approach where the tenant's name reflects the database name. It can also be done through an indirection where you do a lookup into a customer catalog to route these incoming connection requests. So now thinking about this scenario, you have lots of databases for the different tenants, and you manage the capacity for these databases individually. You can see that you have different scale factors, different capacity for different databases that reflects the expected workload for your different tenants. But now imagine that your first tenant on the smallest scale factor is at some point becoming very, very active. That can lead to a situation where you overload the database. Now, with elastic database pools, we make this much easier. You don't have to worry about that situation. It essentially allows individual database capacity to go up and down and follow the demand pattern that you have from your different tenants. So here you can see how the capacity is dynamically going up and down as more or fewer customers, end users, are using a tenant's database. And obviously, you don't want to do that just for a handful of databases. You also obviously want to take this to scale and do this for tens or even hundreds of databases. And you can see that here, the same pattern applies. And you can see how individual databases go up when the load increases, and then they basically go back down. What's interesting about this approach is that you're managing overall capacity for all of these databases that you put into the pool, rather than micromanaging individual resources and capacities for single-tenant databases. So let me actually, and this shows the picture when you think about tens or hundreds of tenants for your SaaS application. Let me show you this concept of elastic database pools at work in Azure SQL DB in a demo. And we're going to jump back into the browser here and into the Azure portal, which you see here. And I have a server set up here, which is this Azure SQL DB server with the 30-odd databases for my SaaS application. So you see Contoso Concert Hall is one of the databases. You can also see that all of these databases are now standalone databases at the S0 scale factor. You may have also noticed the banner in purple up here that says, hey, you might actually want to think about using elastic pools for this server. And let me bring up the next blade here. So what we're doing behind the scenes is we are analyzing your workload and the pattern as it evolves over time. Behind the scenes, we're coming up with recommendations whether it would be beneficial for you from a manageability and a cost perspective to put these databases that you have in your server into a pool. And here, for this example, you can see we're recommending putting all 31 databases into a pool with 100 DTUs capacity. And we're also estimating the monthly savings for you when you do that. So here in this example, you would save around $240. Let's take a look at the details of this recommendation to understand a little bit better how pools work. So here, let me bring up the configure pool blade. And configuring a pool really comes in two parts. The first part is allocating the overall capacity to a pool. And here you can see a slider that I can move. And right now we're at the smallest scale factor, but I can increase this as needed. And that basically governs the overall amount of compute and storage that's being provided for the databases that I've put in the pool. And databases that I've put in the pool, they share the compute and they share the storage. The other part for a pool is providing boundaries for individual databases in terms of how far they can spike up from a capacity perspective. That's the maximum that you see here, the EDTU max setting. And I obviously can tweak that as well or go with the recommendations. And the other part is the minimum boundary, which basically defines the amount of resources that I want to set aside for sure for each individual database. So if I click select here, what will happen behind the scenes is the system will create the pool, move all of the 31 databases from the recommendation into the pool. In terms of connectivity, nothing changes for me. It's still a SQL DB database. I'll use the same connection string to identify and to connect to these databases. Just the resourcing and the capacity aspect is different now. So let's take a look at a pool that I have created. So imagine over time, you're adding more and more databases, more and more tenants into your application. You obviously want to make sure that you have enough resources in your pool. So you can look at the charts here to see whether you're running short of resources. But you can also change the overall resource allocation to your pool, which is very similar to what we just did. So here you're seeing the blade where you can take this existing pool that I have at 100 EDTUs, you can take it up to 200, 400, or all the way to 1200. And that's an online operation. So if you need more capacity, more resources at some point, you can do that without causing any downtime for the tenants and the databases that you have put into your pool. So that's a great way to share resources, to share capacity among tenants, among databases, while keeping the isolation properties of having separate databases for different tenants. So, but still, one of the things that you might think about is now, I'm putting all of those databases into a pool, but I still have lots of databases. How do I manage them? How do I run reports across them? How do I deal with the fact and the implications of having lots of databases for my application? let's start with the first question here, which is essentially running queries across my tenants across many databases. That can be a reporting scenario where you go into Excel, Power BI, or even in Management Studio, and you want to connect to a single place and get an all-up view about what's happening in your data tier with lots of databases in the pool. And the capability that accompanies pools to make that happen is what we call Elastic Database Query. It gives you the ability to connect into a single endpoint, a single SQLDB database, and register essentially the tables that you have spread across your data tier in the pool, register them in a logical view that gives you an insight and single system view across all of the databases that you have in your pool or in your data tier. Let me show you that at work in a demo. And we're going to jump into Visual Studio here. And what you see in Visual Studio is on the left-hand side, actually I pulled open the server that's storing all of the different databases. We've already run across Contoso Concert Hall. So here is the database that stores all the data for Contoso Concert Hall. And you see all the other databases here as well. Now, let's talk about Elastic Query and how to provide that single system view across lots of databases with identical schema. So the first step that you take is you define what we call an external data source, and there's a create external data source statement here, which essentially takes the location of the metadata for your data tier in its parameters and a credential that authenticates it against the databases. That's the first step. The next step, once you've defined essentially the data tier and the databases that participate in the tier through your external data source, you promote tables that you want to establish a single system view for. You promote them into the database that you're currently connected to through what you see here, which is the create external table statement. And you can see we're defining the schema of these tables here. This is a customer configuration table, which is the same on all of the databases in my pool. And we're using the external data source that we just defined in the previous DDL statement. We can do the same for another table, the country table that you see here, 3 columns, again, the same external data source, and the data distribution for it. Let's run this select statement here. I've pre-created all of these external tables, so you see the customer configuration here, and the country is the second external table. And now once we've defined these external tables, we can write regular SQL queries against those tables, or we can use Power Pivot and point to these tables, the external tables in the catalog. They just look like regular SQL Server tables. Let's pick the first one here and run this statement against the customer configuration external table. So this gives us a little breakdown of what are the different templates, customization templates that my tenants are using in their databases. So I can see that a theater is quite popular, so there are 7 tenants that are using that predefined template. Jazz is another one that's very popular, and the next one then is symphony that you see down here. So that gives you some sense about utilization of different features that you have put into your SaaS application. And you can think about similar queries that you may run to find out what is my most profitable tenant, or what are my tenants that cause the most utilization across my databases. Let me run another statement here, which goes against the second table, which essentially shows what countries are my tenants configured to do business with. And all of my tenants here in this example only have the ability to do business in the United States. So 32 tenants do that. Now, all of these examples that we just ran through, we're essentially using horizontal partitioning. So the data was split across multiple databases, having a table with the same schema in each of the databases. There's another partitioning scenario that you can think of that's typically called vertical partitioning, and that schema is different between different databases. And a prominent use case for that is if you put reference data on some database and you manage it in that database, and then you have other multiple databases accessing that common reference data. Again, you can use Elastic Query to provide remote access into a database that stores reference data for you, following exactly the same syntactic concepts. So here, let me illustrate that for you. Here you have a create external data source for reference data. It's using the type RDBMS, which essentially says it's just a standalone remote database. And this is the server name, this is the database name, and here's a credential to authenticate against that remote server. And then we can take, for instance, reference data like zip codes and promote them into my local table here through this create external table statement. Let me run a query against this. And you can see that now there's only one row in there, which is Redmond with its zip code in the United States. And what's great about Elastic Query is you can actually mix and match these external tables that follow horizontal partitioning versus vertical partitioning. You can mix and match them in your queries. So here's an example of a query where you're selecting from a country and joining with the zip code. So country is horizontally partitioned, zip code is vertically partitioned. And when we run this statement, oops, wrong button. Let me run this statement again. So here you can see the result for that. We're counting the number of tenants in the United States, and we're correlating that with the zip code and the city name. So one single statement essentially putting together remote database access for horizontal partitioning and for vertical partitioning. And you can see that in the query plan as well. So let me include the query plan here, run the statement again, and pull up the execution plan here for this query. And make some room on my screen. So here you can see the two remote query operators. This one is the one that goes against country, so that's the one that uses horizontal partitioning. Here's the other one that does the remote table lookup for my reference data. And then here is the implementation of the join between the two, plus some residual aggregation processing that's happening on the head node that I'm connected to. So jumping back into the presentation here. So Elastic Query is a great way to give you access to remote data that's stored in remote SQL DB databases. And it's designed for interactive querying, interactive reporting. Now, if you think about a different scenario, which is you are making changes, schema changes, or maintenance operations to the databases in your pool, in your data tier, how do you do that? In order to do that, what you typically have is a piece of T-SQL, like for instance, updating statistics, rebuilding your indexes, or creating a new table if you change your application. Now, this piece of T-SQL, that needs to be applied to all of the databases that you have in your pool. And what you don't want to do is open individual connections, for instance, from PowerShell to individual databases, and then apply this T-SQL script one at a time. Instead, what you probably would like to do is just have one place that you go to and just drop that piece of T-SQL into the experience and then have it taken care of behind the scenes as it rolls out against the individual databases. And there's a capability that accompanies Elastic Database Pools that does exactly this, and it's called Elastic Database Jobs. And let me jump back into the Azure portal to show you how this Elastic Jobs capability works. So here's the pool that is powering my SaaS application. And you can see the two buttons up here. There's one that allows you to create new jobs. You can give it a name. It will ask you for a credential. And down here, you have essentially a T-SQL editor where you can provide your T-SQL script for the job that you want to run. The second button here is the ability to manage existing jobs, which is great if you have repeating tasks that you need to do once in a while. You can store these as existing predefined jobs here, and you can see I've done that for a couple of times. Here, let me just take this one as an example that I've run earlier today. And what this job does, it essentially inserts a few rows into the customer configuration table that controls which countries tenants in my SaaS application can do business with. And you can see here I'm adding 2 new rows, one for the UK and one for Germany. Let's just pick up this job and run this again. And you can simply hit the run button here, and it will take the existing T-SQL script that is stored with the previous execution of the job and just reapplied to the pool that underlies this job here. And you will see the UI update in a couple of seconds. So what's happening behind the scenes is the job's infrastructure takes that piece of T-SQL and a set of databases that is defined in the pool. And for each of the databases that is in your pool, it creates an individual task. And you can see right now the job is splitting the script and generating these individual tasks. Each task then opens a connection to a database in the pool, and then each connection executes the piece of T-SQL against the database behind the pool, behind the connection. And here you can see how we are making progress against different databases. You can see some of them have already completed the script. Others are still processing it. Here's the next update, and you can see the job succeeded. And let's take a look at what actually happened. And you may remember me running this statement before, and it was just showing results for the United States as the only country where my tenants could do business. So let's rerun this statement. And now you can see that indeed we have added Germany and the United Kingdom to the 32 databases that I have in my pool. So that essentially illustrates that the job really succeeded on all of the databases that I have in my pool. Okay, with that, jumping back into the deck. So you've seen this picture before. This is essentially these 2 dimensions for multi-tenant SaaS applications. One is around tenant isolation that's required for successful SaaS applications in most cases. And then the other one is around cloud resource provider cost and resource sharing. Those were the 3 approaches that you see here on the slide that we've talked about previously. Now, with Elastic Databases and Elastic Pools, you are getting a 4th option that puts you into the upper right corner here, where you can follow the single database per tenant approach, but put all of the tenants into an Elastic Database pool. And by managing your capacity and essentially your cost through the Elastic Database pool, you can reach great resource sharing across all of your different tenants. Now, at the same time, because you're putting each tenant into an individual database, you're also keeping up the level of isolation from a security perspective, from a performance perspective, and from a manageability and troubleshooting perspective for each individual tenant. So this is a great option for you to achieve the best of both worlds without a lot of effort. You can achieve great tenant isolation with great resource sharing at the same time. And if you worry about having lots of databases in your pool or in your data tier, don't worry about it too much. You can use capabilities such as Elastic Query or Elastic Jobs to keep track of all of these databases, to manage them over time, or to query across them. So with that, I'd like to encourage you to check out the Elastic Database capabilities in Azure. And as you download these slides, you'll find a number of useful links on this slide here that point you to the Elastic Database feature overview all up, and then the various features that we talked about today: Elastic Database Pools, Jobs, and Query. Okay, that's all that I have for today. Thank you very much for watching and listening. I hope you found the session useful and hope you're enjoying Build.